Algebra 2, 5.8, Analyze graphs of polynomial functions. Zeros, factors, solutions, and intercepts. So, let f of x equal a sub n times x to the n plus a sub n minus 1 times x to the n minus 1. Continued, a sub 1 x to the first plus a sub 0 will be a polynomial function. The following statements are equivalent. 0. K is the 0 of the polynomial function f. So if k is a 0, that means that x minus k is a factor, because these all mean the same thing. That means that k is a solution of the polynomial equation f of x equals 0. And k is an x-intercept of the graph of the polynomial function if it's a real number. So the graph of f passes through k0. So we are going to graph the function f of x equals 1/6 x plus 3 x minus 2 squared. So from this I know that this is x minus negative 3, and this is obviously x minus 2. So I know that negative 3 and 2 are two of my x-intercepts. 2, 3, 2, 3. So negative 3 and 2 are my x-intercepts. Because this one is squared, it's going to bounce off. And this one's going to go through. So I need to know which side it's going to be on. So now is where I'm going to graph. So 1/6 x plus 3 x minus 2 squared. And we graph it. And it goes up through negative 3, and then it comes down to 2 and bounces off and goes back up. So that is the graph of our function. Okay. Another important characteristic of graphs of polynomial functions is that they have turning points corresponding to local maximum and minimum values. The y-coordinate of a turning point is a local maximum of the function if the point is higher than all nearby points. So this is a local maximum because it's the top of the hill. Nothing near it is higher than it. And the y-coordinate of a turning point is a local minimum. This should say minimum of the function if the point is lower than all nearby points. So if it's at the bottom of a valley, then it's a local minimum. So, turning points of polynomial functions. The graph of every polynomial function of degree n has at most n minus 1 turning points. If a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. So, example 2, graph the function. So we go to y equals x to the third minus 3x squared plus 6. We graph it. So we are going to identify the x-intercepts and the points where local maximums and minimums occur. So we have an x-intercept here. We have a local maximum here where it comes up to the top of a hill. We have a local minimum here where it comes down to the bottom of the valley. So we are going to have one of each. So x-intercept is, we are going to hit second trace. These directions should be on the next page. Yep. Okay. So to find the x-intercept, we're going to do what we did yesterday. So second trace 0. Going to scroll to the left until we're past our 0. And scroll to the right until we're past our 0. And then try to get as close as we can. We get that our x-intercept is negative 1.1960. And now we're going to follow these directions to find our local maximum and minimum. So we've already entered the graph. So now we're going to hit second trace again. And we're going to go down to 3 to find our minimum. So our minimum. And our minimum is over here. So I'm going to scroll over here. Okay, we have to be left of it first, so I'm going to go left a little bit again, hit enter. Then I have to go past it to the right, and hit enter. And then I have to get as close to it as I can, and hit enter. And our minimum is 1.9 repeating 2. That's our local minimum. And now we have a local maximum. So second trace, and then we go down to maximum. We have to go to the left of our maximum, then to the right, and then as close to it as we can get. And our maximum is 0.6. Okay. So then for g of x here, for part B, we're going to repeat the same process. So we enter in our equation 6x to the third plus 3x squared plus 10x minus 3. Let's go into graph. So I have a couple of x-intercepts here. I have 3, 4, looks like. So I can have up to 4. So to find my 0, I hit second trace 0. I'm going to go left of this first one. And I'm going to go right of it. Then I'm going to guess. So my first x-intercept is negative 1.137. Second trace 0. I'm going to go left of this second one, and then right of it, and then as close to it as I can get, and I get 0.289. And then second trace, going left of this one, going right of it, guessing, I get 1.816. And then for this last one, get 5.033. Okay, now I have to look at this. I have my graph coming down, and then it switches to coming back up. So I have a minimum here, and then it's going up, and then it goes back down. So I have a maximum here, and then down here somewhere I'm going to have another minimum. So I'm going to change my window and have my y minimum, because I want to see lower, be negative 20, and see if that covers it. So, nope, still can't see it, so I'm going to change it even lower, -30. Still can't, so I'm going to change it a little bit more. There we go. So I have a minimum, a maximum, and then another minimum. So I'm going to have 2 minimums and 1 maximum. So second trace, and I'm going to go down to minimum. I go left of this first one, and I'm going to go right of it, and I'm going to get pretty close. And my minimum is at -0.570 because it rounds up, -6.509, and then I'm going to find my other minimum over here. I'm going to go more to the right. So I'm still left of it, so I'm going to hit enter. And I'm going to go right of it and hit enter and get close to it. So my other minimum here is 3.962, -43.038. And then my local maximum is, I gotta go left of it again, and I gotta go right of it, and then I'm gonna guess 1.108, 5.109. So that is my local maximum. So now for example 2, we are given our graphs a little bit different. So this one, we can identify the x-intercepts right away because it's already in intercept form. So we take the opposite of this, so we get x-intercepts are at -2, take the opposite of this, +1, and +3. So those are our 3 x-intercepts. So now I'm going to graph it on my calculator and make sure that I'm right. X + 2, x - 1, x - 3. Okay, and to change this back to my regular window, I'm going to hit zoom, and then 6, which is zoom standard, and that'll make it turn back into the regular window. So there we go. So our local min and local max. So we have 1 of each. Okay, and we can tell that using our rule back here. So if a polynomial function has n distinct real zeros, so we had 3 different zeros on this one. We had -2, 1, and 3. So we had 3 distinct real zeros, so it's going to have exactly n - 1 turning points. So if it had 3 real zeros, it's going to have 2 turning points. We have 1 turning point up here and another turning point down here. Okay, so it's how many times our graph goes from increasing to decreasing. Okay, so local minimum is here. So, second trace, looking for my minimum. I am left of it, and I'm going to scroll right of it, and then I'm going to guess, and I get 2.120 because it rounds up, negative 1.015. And for my local maximum, it's second trace, go to maximum, I gotta go left of it, hit enter, go right of it, hit enter, then get real close to it, hit enter, and I get negative 0.786, 2.052. Okay. And then for g of x, it's not in intercept form, so we can't come up with how many x-intercepts we're going to have. We're going to have a maximum of 4, but we're not sure that it is exactly 4. So, that minus 4x minus 5. Graphing it. 1, 2 zeros. So I only have 2 zeros. So then I am going to find the x-intercepts, and then I have 2 local minimums, one here and one here, and 1 local max. Second trace, 0. Gotta go left of it, and then I gotta go right of it, and then I gotta guess. And I get negative 3.074. And second trace, 0. And I get 1.422. Oops. And then I hit second trace, go down to minimum, go left of my minimum, then go right of my minimum, then I guess, I get negative 2.277, negative 9.612, second minimum, left, right, guess, 0.676, negative 7.025. Calculate, and then maximum, gotta go left of it, hit enter, right of it, hit enter, guess, and I get negative 0.650, negative 3.468. And there we go.